For decades, Antarctica has been treated as a silent continent, frozen, empty, and obedient to science. But occasionally, the ice whispers something different. In the last 20 years, radar scans have revealed a shifting shadow deep beneath the ice sheet. A mass so large and so mobile that early researchers believed their instruments were malfunctioning. What they discovered reshaped the mystery entirely. Subscribe if you want more stories that make the world feel bigger than we imagined. Antarctica's surface often steals attention with its endless white plains. But the continent's true secrets lie beneath the ice. 2 miles down, ancient bedrock, hidden lakes, and unknown geological formations form a world more alien than most planets we explore. Scientists describe this subsurface as a black box, a region mapped by instruments, not sight. In that darkness, unexpected anomalies are not only possible, but surprisingly common. The mystery began in the early 2000s when scientists, studying subglacial water channels, noticed an unusual distortion on their radar readings. At first, they believed it was a calibration issue. The signal was too clean, too defined, suggesting an object or mass interrupting the radar pulse. It appeared as a moving shadow, shifting position between scans taken months apart, challenging every expectation of what should exist under the ice. Ice-penetrating radar typically reveals smooth layers of compressed snow, pockets of meltwater, and occasionally buried mountain ranges. But this anomaly produced an outline that did not match ice, water, rock, or sediment. Its edges blurred under certain frequencies, yet sharpened under others. It absorbed some wavelengths and reflected others. The behavior was inconsistent with any known geological formation, forcing teams to revisit their data repeatedly. At first, researchers suspected a massive, slow-moving block of ice descending through a subglacial cavity. But simulations showed this explanation failed. The shape was too defined, and its apparent movement was lateral, not downward. Ice behaves predictably, responding to gravity and temperature. This shadow behaved like neither. It felt almost intentional, moving along a path that did not correlate with known glacial flow. Antarctica experienced only limited exploration before the mid-20th century, leaving many regions entirely unmapped. That historical gap adds mystique to anomalies like this. Early explorers wrote of strange vibrations beneath the ice, noises like distant thunder and ground tremors with no obvious source. Though many can be explained by shifting glaciers, others remain unclear. These older accounts set the stage for modern mysteries. When the anomaly appeared again during a 2007 radar sweep in a location nearly 30 kilometers from its original position, the scientific community took notice. A moving mass of that size, larger than most whales and deeper than any creature should survive, posed a question no one had asked. Could something be living, growing, or evolving beneath the Antarctic crust in isolation for millions of years? Biologists objected immediately. No known organism, not even the largest blue whale, could thrive in subglacial conditions without oxygen or sunlight. Temperatures beneath the Antarctic ice sheet can reach extreme lows, and pressure levels would crush any biological structure not specially adapted. Yet geophysicists argued the question was worth exploring, not because life was likely, but because the data did not align neatly with non-living explanations. Much of Antarctica's mystery stems from its hidden lakes, over 400 of them sealed beneath the ice for millions of years. Lake Vostok, the largest, holds more water than many surface lakes on Earth. Its ecosystem has been isolated for so long that scientists believe unique microbial species exist within it. The existence of such locked-away environments gives context to the anomaly. Antarctica is full of biological surprises. But the shadow scale remains the sticking point. Subglacial lakes may hold life, but this mass spans hundreds of meters, too large to be a cluster of microbes, too dynamic to be pure geology. Its surface signature changes slightly over time, suggesting flexibility or temperature variance. Satellite gravimetric readings even detected a faint but measurable mass displacement, further complicating the mystery. In 2012, NASA's Operation Icebridge conducted additional flights over the region using advanced radar and laser altimetry. The anomaly reappeared again, larger, clearer, and more complex. Instruments detected a slight electromagnetic disturbance localized around the mass, a signal pattern not typical of rock or sediment. Analysts debated whether this reflected metallic content or an unknown mineral composition. Geologists proposed that the mass might be an enormous block of ultradense rock dragged by glacial forces. but seismic imaging later contradicted this theory. The anomaly lacked the acoustic signature of rock. Instead, it absorbed seismic waves in a manner consistent with porous material, not solid. This surprising behavior reopened theories involving ancient ice formations or deep pockets of trapped organic matter. Organic matter presents its own challenges. For a mass that size to be organic, it would have to be a remnant of prehistoric forests or peat deposits from when Antarctica was warm. But organic deposits do not migrate sideways across subglacial plains. They stay buried, inert, and compressed. None of the typical organic decay gases were detectable in the region, making this explanation unlikely. In the mid-2010s, the anomaly became the focus of an international study. Scientists from the US, UK, Germany, and Japan collaborated to compare radar signatures, seismic readings, magnetic surveys, and thermal imaging. The result was both fascinating and unsettling. Every type of scan confirmed the mass existed, yet none could identify what it was. Each discipline saw something different, as if the shadow refused to match any one category. One proposal gaining traction among glaciologists was that the anomaly represented a massive, subglacial cavern partially filled with meltwater. Caverns can distort radar signals and shift as the ice above them moves. But the dimensions here were far larger than typical caverns, and the so-called movement was inconsistent with water migration. It seemed to shift independently from ice flow models. The question of movement remains the anomaly's most puzzling trait. Between 2001 and 2015, the mass appeared in 3 distinct locations, never suddenly, always gradually. The shifts aligned neither with glacial flow nor tectonic movement. If the readings were accurate, something underground was migrating at a rate impossible for rock and improbable for ice. A team studying Lake Whillans offered a potential clue. They discovered microbial mats surviving under extreme darkness using chemical energy rather than sunlight. These organisms represent some of the oldest life strategies on Earth. Their existence shows that life beneath the ice is not just possible but active. Yet nothing in that ecosystem approaches the scale of the anomaly. Historical logs from mid-century expeditions describe regions where compasses behaved erratically and radio signals weakened unexpectedly. Some of these events correlate with the anomaly's approximate locations. While magnetic disturbances can be caused by underground minerals, the pattern here seemed irregular. The patches of interference were strong but localized another puzzle point for researchers. The anomaly began gaining public attention when leaked maps from a research presentation circulated online. Though the original context was scientific, speculation exploded into claims of giant creatures or buried technology. Scientists quickly stepped in, emphasizing non-biological explanations. But they also admitted something rare in academic circles. The anomaly remained unsolved, not dismissed. To separate fact from myth, researchers revisited the raw data. High-resolution radar imaging revealed the mass had an irregular outline, smooth in some areas, jagged in others. This asymmetry hints at layered composition, possibly involving ice, sediment, or trapped pockets of melt. Still, the mass's scale exceeded known subglacial structures, making simple explanations insufficient. In 2018, a new generation of sensors detected faint heat signatures beneath the ice near the anomaly. Temperatures were slightly elevated compared to surrounding regions, suggesting geothermal activity or friction-induced heat. The presence of warmth raised questions. Was the mass resting on an active geothermal vent? Or was movement generating heat through pressure and sliding? One fascinating theory emerged. The mass might be a fragment of an ancient mountain range buried beneath kilometers of ice. Antarctica once had dramatic landscapes before freezing over. But geological deposits this large should be static, not mobile. And this hypothesis still fails to explain the electromagnetic readings that imply non-geological material. Another interpretation involves subglacial water transport. Antarctica's underground water network behaves like a hidden circulatory system filling lakes, draining them and shifting pathways. A large moving pocket of supercooled water could distort radar signatures. But the anomaly's density readings were too high for water alone, pointing again to something more complex. As more data accumulated, some researchers proposed a hybrid theory, a massive mixed material structure, part rock, part ice, part unknown sediment, moving along a deep basal channel shaped by ancient tectonics. This explanation might fit the movement but not the electromagnetic oddities or the heat signature. Each explanation solves one piece while leaving others unexplained. The anomaly's size continued to grow as measurements expanded. Revised estimates suggested a mass over several hundred meters across, larger than the Empire State Building. Such dimensions are not unprecedented in geology, but the lack of seismic clarity and the mobility remain unparalleled. Scientists began referring to the phenomenon informally as the Antarctic shadow. During a 2020 radar sweep, a surprising detail emerged. The mass appeared to distort the ice layers above it in subtle but visible ways. These deformations resembled pressure patterns seen in glacial interactions with buried ridges or subglacial mounts, yet the shape did not match any known ridge system. The distortion suggested a slow but persistent upward force. Some researchers speculated the force could represent buoyant uplift caused by a buried structure composed of unique minerals. If the mass were lighter or denser than surrounding rock in unusual ways, it could create unpredictable pressure effects. But without drilling, nearly impossible in that region, confirmation remains out of reach. In 2021, a multinational team returned with improved gravimetric sensors. They discovered slight fluctuations in gravitational pull above the anomaly, indicating that the mass had a density profile unlike typical Antarctic geology. These findings ruled out simple explanations such as sediment dunes or loose moraine deposits. Whatever the mass is, it has internal structure. Around the same time, satellite ice velocity maps revealed faint streaks in the ice that matched the anomaly's suspected path. These streaks were not carved or melted but subtly displaced. They suggested that not only was something moving beneath the ice, but it had been moving for decades or perhaps centuries. Subglacial movement is not unheard of. Massive ice streams can flow rapidly, carving deep channels. But the anomaly diverges from these systems. It moves differently, less predictable, more directional. The movement resembles drift rather than flow, raising questions about forces at play beneath the ice sheet. One of the leading non-biological theories today is that the anomaly may be a massive chunk of ancient crust detached millions of years ago during tectonic shifts. As Antarctica froze and thickened, this detached crustal block could have been pushed slowly along a lubricated basal layer by ice pressure. While viable, it still fails to explain heat signatures and electromagnetic irregularities. A second major theory suggests that the mass could be a buried volcanic plug, a remnant of an extinct volcano that has since been dragged by glacial movement. Volcanic plugs are dense and can distort instruments, but they do not move easily beneath ice, making this theory workable for some observations but incompatible with displacement data. The creature-related theories popular online are not taken seriously by biologists. No organism of that size could survive in such conditions, and the available data do not indicate biological movement patterns. The anomaly lacks rhythmic changes or thermal signatures expected from metabolizing organisms. Still, the idea persists because the human imagination gravitates toward living mysteries. What makes the Antarctic shadow compelling is not the fear of a colossal creature, but the clear scientific puzzle it represents. Every year, new technologies reveal more about Earth's least accessible continent. Yet the anomaly remains stubbornly ambiguous, big enough to be undeniable, unusual enough to resist classification, and elusive enough to spark debate. By 2022, the anomaly had become a case study in scientific humility. Conferences dedicated sessions to subglacial unknowns, acknowledging that Antarctica still hides structures larger than skyscrapers. Rather than dismissing the shadow, researchers began exploring parallel mysteries like Lake Vostok's unexplained pressure waves and Dome A's unusual magnetic anomalies. One possibility gaining traction is that multiple phenomena are interacting: geothermal heat, subglacial water migration, mineral-rich bedrock, and deep ice deformation. Together, these could create a composite radar signature that appears as a single object. This explanation fits some patterns but fails to account for the observed lateral movement. Meanwhile, satellite gravimetry continues to detect small changes in mass under the ice sheet, indicating dynamic geological processes. Antarctica is not the static frozen wasteland many imagine. Beneath the surface, hundreds of active and dormant features, volcanoes, rifts, and subglacial lakes interact constantly. In this restless environment, the Antarctic shadow might be just one piece of a larger, hidden system. Researchers studying the Gamburtsov, subglacial mountains, an entire mountain range buried under ice, use similar techniques to investigate the anomaly. Their work shows that buried peaks and valleys can create radar illusions. But none of those known formations produce the mobile, morphing signature of the shadow, suggesting a fundamentally different phenomenon. A lesser-known factor involves Earth's mantle dynamics. Some geologists propose that mantle plumes, rising from deep within the planet, could create shifting pockets of geothermal energy. These plumes might cause melting, sliding, and movement beneath the ice. If the Antarctic shadow rests atop such a plume, its movement might be indirectly driven by mantle activity rather than by its own nature. Still, every new dataset complicates the picture further. The anomaly's edges sometimes appear sharper, sometimes more diffuse. Radar cross-sections taken only days apart can differ subtly, suggesting surface changes or internal shifts. Such variability is difficult to reconcile with static geological features, leaving room for interpretations involving dynamic processes previously unknown. Antarctica's unique insulation, its thick ice sheet, creates environments where data behaves unexpectedly. Radio waves refract, seismic pulses scatter, and gravitational fields warp due to varying ice densities. Researchers caution that the anomaly's strangeness may reflect our limited understanding of deep ice physics, rather than an exotic object lurking below. Yet the mass is undeniably real. Its presence has been confirmed by independent teams using different instruments across 2 decades. Even skeptics admit the data is consistent. Something massive, irregular, and mobile exists under the Antarctic ice. The puzzle is not whether the shadow exists, but what combination of forces can create such a signature. One striking idea proposes that the mass may be a relic glacier, composed of ancient ice trapped between rock layers, slowly freed by geothermal heat. If this glacier contains dense mineral inclusions, it could generate mixed radar and seismic signatures. Its movement could be driven by deeper water channels carving new pathways beneath it. Another possibility involves buried meteorite fragments or even an impact structure. Antarctica is known to preserve meteorites exceptionally well. A large extraterrestrial impact could theoretically leave behind dense material with unusual magnetic and seismic characteristics. But intact meteorites do not migrate, leaving this theory incomplete. The most comprehensive interpretation today suggests that the Antarctic shadow may be a moving composite mass, a shifting mixture of supercooled water, ancient ice, mineral-rich sediment, and geothermal activity. This model explains electromagnetic variance, partial heat signatures, and unusual motion patterns. But even this theory lacks full evidence, keeping the mystery alive. What scientists agree on is that the anomaly is not a creature or a lost civilization. It is part of a natural system, one we barely understand. The mystery persists not because researchers hide the truth, but because Antarctica itself remains a frontier where instruments struggle and nature writes in unfamiliar patterns. In recent years, the focus has shifted from identifying the mass to understanding what it reveals about Antarctica's unseen mechanics. If such a large structure can move and evolve under the ice, then the continent's subsurface may be far more dynamic than previously thought, with implications for climate modeling, ice stability, and future sea level predictions. Deep beneath the ice, the shadow continues to drift slowly, indifferent to curiosity. Every new scan adds detail, yet deepens the enigma. The scientific community waits for the next breakthrough, whether from advanced sensors, seismic networks, or perhaps one day a drilling expedition. Until then, the Antarctic shadow remains a silent traveler. Its story is a reminder that Earth still holds secrets vast enough to challenge modern understanding. Not all mysteries lie in the cosmos. Some rest beneath our feet in places humanity has barely touched. Antarctica's deep underside is a world waiting for discovery, where every anomaly is a doorway to deeper questions. The massive shadow beneath Antarctica may not be a creature, but it is no less extraordinary. It represents a phenomenon bigger and stranger than familiar categories, something shaped by time, ice, and the restless geology beneath Earth's coldest continent. Until science unlocks its identity, it stands as one of the planet's most compelling enigmas, reminding us how much of our world remains unseen.